Every night you look up at the sky, you see darkness. But according to the maths, the night sky shouldn't be dark at all. If the universe is infinite and filled with over 100 sextillion stars, the entire sky should be glowing as bright as the surface of the sun. And yet, space is black. This contradiction has puzzled some of the greatest scientists in history, because by all accounts of logic, the darkness of space should be impossible. So, what are we missing? And where did all the light go? Let's dive into it. For centuries, some of history's greatest astronomers struggled with this contradiction. It eventually became known as Olbers Paradox back in the 1820s. On one hand, our eyes see a dark night sky. On the other hand, basic geometry suggests that if the universe was static, infinite, and filled with stars, every point of the sky should eventually contain starlight. Imagine standing inside an infinitely large forest. No matter which direction you look, your line of sight eventually hits a tree. Now replace every tree with a star, the same logic should apply. The night sky shouldn't contain dark gaps at all. Early astronomers did propose an answer. Maybe enormous clouds of dust were simply blocking the light. Sounds reasonable. Except physics immediately ruins this idea. You cannot hide energy forever. If cosmic dust absorbs starlight for billions of years, the dust itself heats up. Eventually, it starts radiating its own energy instead. So the dust simply becomes another source of light. Dust cannot solve this paradox. So maybe the answer is much simpler. Maybe the night sky is dark because stars don't live forever? That's right. Every star is burning through a limited fuel supply. Massive stars shine incredibly bright, but survive for only a few million years before exploding. Stars like our sun live much longer, billions of years. But eventually, they run out of fuel too. They expand, collapse, and fade into dark stellar remnants. The universe is constantly changing. In fact, the universe passed its peak star-forming era roughly 10 billion years ago. Astronomers call this period cosmic noon. Today, new stars are forming slower than before, and slowly the universe is running out of fuel. The lights are gradually turning off. And for a moment, this seems like the answer. After all, if stars keep dying, maybe the universe simply doesn't have enough light left. But there's one enormous problem. Even if every star eventually dies, the light should still be traveling through space, and the early universe itself was unimaginably bright. So, where did all of that light go? Maybe some of the light simply hasn't arrived yet? We tend to think of light as instantaneous. You flip a switch and the room lights up immediately. But light isn't magic. It's a physical wave traveling through space at a finite speed. Exactly 299,792,458 meters per second. Fast, but not infinitely fast. When you look at a star 4 light years away, you're not seeing it as it exists right now. You're seeing it as it existed 4 years ago. You're literally staring into the past. And this changes everything. The universe had a beginning about 13.8 billion years ago. That means light has only had 13.8 billion years to travel. There simply hasn't been enough time for light from infinitely distant regions to reach us. Some parts of the universe are so far away, their light is still on the journey. It's simply running late. But this still doesn't completely solve the paradox, because the first light from the incredibly hot early universe should have reached us by now. So once again, where is it? The answer lies in something that we cannot see. Space itself is expanding in all directions. And as light travels through expanding space, the light wave itself gets stretched. Now you might wonder, if light gets stretched, then why don't we get stretched too? That's because gravity and electromagnetic forces are enormously stronger than cosmic expansion on smaller scales. Galaxies, solar system, planets, and even your own body are held together far too tightly to be pulled apart. The expansion of the universe only becomes noticeable across unimaginably huge distances between galaxies. And unlike objects held together by gravity and electromagnetic forces, light traveling through expanding space gets stretched. Its wavelength becomes longer, and longer wavelengths carry less energy. Visible light slowly shifts toward red. Red light is the longest wavelength that our eyes can still detect. Stretch it just a little further and it moves beyond the limits of human vision. This invisible light is called infrared. You can't see infrared, but you can still feel it. It's the warmth that you feel from sunlight on your skin. It's also the radiation emitted by warm objects. But space keeps stretching the light even further. Eventually, the wavelengths become so long that it enters the microwave region, the same type of electromagnetic wave used by microwave ovens. At this point, the light hasn't disappeared. It's simply stretched so much that human eyes are physically incapable of detecting it. And suddenly, the mystery begins to disappear. The ancient light from the early universe never vanished, it simply changed form. The universe isn't necessarily dark. Our eyes are just simply incapable of seeing most of its light. But what if you could see microwaves? The darkness of space would instantly disappear. In every direction, the universe would glow. The entire sky would be filled with a faint, uniform light. This glow is called the cosmic microwave background. It's the oldest light we can observe, the thermal echo of the Big Bang itself. Every cubic centimeter of space is filled with it. To a microwave telescope, space isn't black at all. It's bright everywhere. The darkness we see is simply an illusion created by the limitations of human vision. So why is space so black? Because universe has a beginning, because stars don't live forever, because space itself is expanding and stretching ancient light into wavelengths invisible to human eyes, and because human vision can only perceive a tiny fraction of reality. The darkness of space isn't evidence of emptiness, it's evidence of a living, evolving universe. Trillions of years from now, future civilizations may look up and see nothing at all. No distant galaxies, no clues about the universe beyond their own galaxy. They may genuinely believe they're completely alone. But today, we can still see the fingerprints of the universe's birth. And that means every dark night sky above us is actually hiding one of the greatest stories ever told. If you're curious about more mysteries like this, consider subscribing because there are still plenty of impossible questions left to answer.